Get ready for a mind-bending journey into the cosmos. 10 years ago, a groundbreaking discovery shook the world of astronomy, and today we're celebrating a new milestone. The universe just got a little louder, and it's telling us something incredible. Back in 2015, scientists detected gravitational waves for the first time, confirming a key prediction by the legendary Albert Einstein. This discovery opened up a whole new era of astronomy, and now, a decade later, we're witnessing another remarkable event. Enter Stephen Hawking, the brilliant mind who left an indelible mark on science. A new gravitational wave discovery has put his theories to the test, and the results are nothing short of astonishing. But first, let's unravel the mystery of gravitational waves. Imagine the universe as a giant fabric, and these waves are like ripples traveling at the speed of light. They're caused by massive accelerated objects like black holes colliding or the mergers of neutron stars. It's like the universe is whispering to us, and we're finally learning its language. On September 14th, 2015, the twin laser interferometer gravitational wave observatories, LIGO, in the US, picked up the first direct observation of these waves. The signal, GW15014, originated from a collision of two black holes, each more massive than 30 suns, located over 1 billion light-years away. This discovery was a direct proof of Einstein's theory of relativity, and it earned Rainer Weiss, Barry Barish and Kip Thorne the 2017 Nobel Prize in Physics for their groundbreaking work. Since then, LIGO, along with the Italian Virgo and Japanese KAGRA detectors, have observed over 300 gravitational waves. Just a few weeks ago, the international LIGO-Virgo-KAGRA collaboration released their latest findings, doubling the number of known waves. And now, on the anniversary of that first discovery, an international team including Australian scientists from the Australian Research Council's Centre of Excellence for Gravitational Wave Discovery, OSGRAV, has announced a new gravitational wave signal, GW250114. Here's the exciting part. GW250114 is almost identical to the very first signal, GW15014. The black hole collision that produced GW25014 had very similar physical properties, but thanks to significant upgrades in the detectors over the past decade, this new signal is much clearer and almost 4 times louder. But here's where it gets controversial. Stephen Hawking, the renowned physicist, had his own set of laws describing black holes, and now we have the chance to test them. Hawking's second law of black hole mechanics, also known as Hawking's area theorem, states that the area of a black hole's event horizon must always increase. In simpler terms, black holes can't shrink. Meanwhile, Jacob Bekenstein showed that a black hole's area is directly related to its entropy, a measure of disorder. The second law of thermodynamics tells us that entropy always increases, and so does the universe's messiness. Since a black hole's entropy must increase with time, its area must also grow. So, how do we test these ideas? Colliding black holes, it turns out, are the perfect laboratory. The precision of this recent measurement allowed scientists to perform the most accurate test of Hawking's area theorem to date. Previous tests using GW150141 showed good agreement with Hawking's law, but couldn't provide a conclusive confirmation. Black holes are surprisingly simple. Their horizon area depends only on mass and spin, the essential parameters to describe an astrophysical black hole. The masses and spins of the incoming black holes and the final black hole left after the collision determine the gravitational wave's appearance. By separately measuring these parameters, scientists compared the areas of the individual colliding black holes to the area of the final black hole. The data showed an excellent match with the theoretical prediction that the area should increase, confirming Hawking's law beyond a doubt. And this is the part most people miss. Black holes are simple, yet they hold the key to understanding the universe's messiness and its fundamental laws. So, who's next in line for a scientific test drive? Future gravitational wave observations will allow us to explore more exotic theories, and perhaps even uncover the nature of the universe's missing components, dark matter and dark energy. Get ready for more mind-blowing discoveries, because the universe has only just begun to speak to us.